Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is continuity and differentiability. In this video, we'll be focusing on NCERT solutions for exercise 1 which is dealing with continuity. The first problem, we need to see whether this function is continuous at these points. Now, the function f of x equal to 5x minus 3, right hand side we see here, this is a polynomial. All polynomial functions are continuous, that we have seen. So this function is continuous at all points including x equal to 0, x equal to minus 3 and x equal to 5. Continuous, in fact it is continuous for all x belonging to the real numbers. Now examine the continuity of the function. Again we have a function f of x equal to 2x square minus 1. This is again a polynomial function. So this is continuous, and in fact this function is continuous at x equal to 3 and in fact for all x belonging to R. Now we need to examine the following functions for continuity. Let us take a f of x equal to x minus 3. This is a polynomial function which is continuous. Now we take expression b, f of x equal to 1 by x minus 5, x not equal to 5. What happens at x equal to 5? Denominator will become 0 and the function will be undefined. But if we ignore x not equal to 5, it is continuous at all other points because it is a rational function. We see a constant up and in the denominator we see a polynomial. So this is continuous again, continuous function except x not equal to 5. Except at x equal to 5 it is continuous. Similarly C also we see f of x equal to x square minus 25 by x plus 5. Clearly x cannot be 5 minus 5. What happens if x becomes minus 5? This denominator will be 0 and the function will be undefined. We see a polynomial on numerator and a polynomial on denominator. It is again a continuous function except x equal to minus 5. Now in the fourth case, we want to check mod x minus 5 is continuous or not. So mod x minus 5 can be written as x minus 5, x minus 5 greater than 0, x minus 5 less than 0. Here we put a negative sign. This is the definition of mod. So this can be rewritten as x greater than 5 and x less than 5. Now we want to check what happens at x equal to 5. At x equal to 5, limit x tending towards 5 minus on the lower side. So this equation will be using minus 5 minus 5 which is 0. Similarly limit x tending towards 5 plus side. So we will be using this equation equal to 5 minus 5 which is again 0. Also f of 5, let us see what happens to f of 5. So this again this expression will be used. So 5 minus 5 will be equal to 0. Now the function value is equal to the limit value. Hence the function is continuous at x equal to 5. Function is continuous at x, and when it is greater than 0, when x is greater than or equal to 5, it is always continuous because this is a polynomial. Similarly at less than 5, this function is continuous because this is a polynomial. Hence we can say, and at x equal to 5 also continuous. So this function is continuous for all x belonging to. We need to prove that f of x equal to xn, x equal to n. We need to prove that the function is continuous at this point. So again we use the same rule. Function definition, function at x defined at x equal to n should be equal to the limit value, limit x tending towards n f of n of x. That's what we are doing here. On the right side, first we compute the function value f of n. We substitute x equal to n, we get function value as n power n. Now we take the limit f of x, function is x power n, we substitute x equal to n, get n power n. So the limit value is equal to the function value, hence the function is continuous at x equal to n. Now in this we want to check whether the function is continuous at these points. What happens at x equal to 0? X equal to 0 is this. It lies in this region because this is x less than or equal to 1. We have a polynomial here x. So at x equal to 0, f of x is continuous. What happens at x equal to 2? X equal to 2 will lie in this region. At x equal to 2, f of x is constant value, which is continuous. This is also continuous. Now we need to check at x equal to 1 what happens. So let us define f of 1 first. F of 1 will be coming here, which is 1 itself. Now limit x tending towards 1 minus, will go from the lower side, which is x equal to x, which is 1. Limit x tending towards 1 plus side, so we will come from here, which is equal to 5. So we observe that left hand limit is not equal to right hand limit, not equal to, hence the function is not continuous at x equal to 1. Find all possible discontinuities of this at this point. So we got this. Now it can be continuous at when x less than minus 3 equal to minus 3. We can get different cases observing this function here. Now let us see one by one. What happens when x is less than minus 3? It will belong to this state. X less than minus 3 will belong to this place. So this is mod x is a continuous function and this is a constant. So this is continuous. F of x is continuous here. What happens to this region? Again, this is equal to a polynomial. This is again a continuous function. F of x is continuous. What happens to greater than 3? We again get a polynomial here. So f of x is again continuous. Now what happens to x equal to minus 3 and plus 3? We will be evaluating this. Let's do minus 3 first. So limit x tending towards 3 minus. So that will be f of x will be minus 3 mod plus 3 will be equal to 6. Similarly, limit x tending towards minus 3 plus side coming from here. So this will be here. So this will be minus 2 into minus 3, which is 6. Further, f of minus 3, that will be here, will be mod of minus 3 plus 3 equal to 6. We observed that the function value and the left and right hand limits are equal. The function f of x is continuous at x equal to minus 3. Let us see at x equal to 3 what happens. So we will again put here limit x tending towards 3 minus. So it will be here minus 2x minus 2 into 3, which is minus 6. Limit x tending towards 3 plus, say, let us come. So we will put here. So this will be 6 into 3 plus 2, which is 20. Left hand limit is not equal to right hand limit. The function is not continuous at x equal to 3. Now we have another interesting problem here. Now we observe that mod x is a continuous function and x is a polynomial. So at x not equal to 0, f of x is continuous. But what happens at x equal to 0? We will try to find it out. At x equal to 0, what will happen? Let us see. So we put limit extending towards 0 minus f of x equal to limit h tending towards 0 f of 0 minus h equal to f of minus h, which is equal to minus h by minus h. This is h, this will be minus 1. Now similarly, limit x tending towards 0 plus f of x equal to limit h tending towards 0 f of 0 plus h equal to f of h equal to mod h by h. This is 1. Left hand limit is not equal to right hand limit. The function is not continuous at x equal to 0. In this problem, we need to find the points of discontinuity of f defined by this function. Now, clearly we see that for x greater than 0, f of x is constant, so it is continuous. It is continuous for x greater than 0. Similarly, what happens when x less than 0? F of x is x by mod x. Now both numerator and denominator are continuous functions. So as per theorem, f of x is continuous for x less than 0. Now what happens at x equal to 0? That is the question. So that we are trying to find it out. Let us, so at x0, the left hand limit should be equal to right hand limit should be equal to f of 0. Then it is continuous at x equal to 0. Let us try to find out. So limit x tending towards 0, positive side. From positive we are coming. So we are coming from here. So it will be minus 1. F of x will be minus 1. So what happens now? Limit x tending towards 0 minus f of x. So we have to use this expression. So this can be written as limit h tending towards 0 f of 0 minus h. We know how to do it this. So this will be equal to limit h tending towards 0 f of minus h. So this will put it, this will be minus h by mod minus h. So this will be equal to minus 1. Now this left hand and right hand limits are same, but we have to check f of 0 also. So f of 0 will be, we have to use this expression again because this is f of 0. F of 0 is minus 1. So now f of 0 is equal to limit x tending towards 0 plus f of x is equal to limit x tending towards 0 minus f of x. So the function is continuous at x equal to 0. So it is continuous for all r. So f of x continuous is continuous for all r. for all x belonging to R, you can say. Find all points of discontinuities of where f is defined by this. Now, what happens when x less than 2? X less than 2, this is a polynomial function, so it is continuous. F of x is continuous. What happens when x greater than 2? Again, this is a polynomial function, so f of x is continuous. What happens at x equal to 2? That we need to find it out. So we will find it out. Limit extending towards 2, say minus, we'll put it, f of x. So we'll put 2 here in this expression, 2 cube minus 3, which is 5. Similarly, limit extending towards 2 plus side, f of x. So we'll use this expression now. 2 square plus 1 equal to 5. We'll check f of 2 also. F of 2 is belonging to this. So that will be 2 cube minus 3, which is 5. So all these three are equal. F of 0 is equal to left hand limit and right hand limit. Hence, f of x is continuous at x equal to 2. So it is continuous. F of x is continuous for all x belonging to real numbers. So it is continuous for all real numbers. Find point of discontinuity where f is defined by this. So let us see, for x less than 1, this function is continuous because it is a polynomial. F of x is continuous. For x greater than 1, also this is a polynomial function. F of x is continuous. Now question comes, what happens at x equal to 1? So we'll do limit extending towards 1. Minus sign means from the negative side will come, so we'll use this expression, 1 power 10 minus 1, which is 0. Or limit extending towards 1 plus side will come, so we'll use this expression. So f of x will be equal to 1 square, which is 1. So we see that the two limits, left hand limit is not equal to right hand limit. F of x is discontinuous or not continuous at x equal to 1. Discuss the continuity of the function defined by this. Now clearly the critical points in this function are 1 and 3. So at this point we need to check discontinuity. Other places the function is continuous. So other ranges, this range function is continuous, this range function is continuous. Only at x equal to 1 and x equal to 3 we need to check. At x equal to 1, x equal to 3 need to be checked. So we can check limit x tending towards 1 minus is 3. Limit x tending towards 1 plus is f of x is equal to 4. So they are not equal. Left hand limit not equal to right hand limit. So f of x not continuous at x equal to 1. Now let us try other one. Limit x tending towards 3 minus f of x equal to 4. Limit x tending towards 3 plus f of x is equal to 5. So again left hand limit not equal to right hand limit. F of x is not continuous at x equal to 3. In this problem, we are given a function f of x equal to 2x when x is less than 0, equal to 0 when x is between 0 and 1, and 4x when x is greater than 1. Clearly, when x less than 0, function is continuous because f of x is equal to 2x, which is a polynomial, so it is continuous. And similarly for x greater than 1, f of x is equal to 4x. Again it is continuous because this being a polynomial function. Now the question comes, what happens at x equal to 0 and at x equal to 1? That we need to check it. So let us check at x equal to 0. So limit x tending towards 0 minus, so we will come from this side, f of x equal to 2 into 0, which is 0. Similarly, limit extending towards 0 plus side, so we will come from this, which is already 0. Also f of 0 is 0 from here given. So the function value at x equal to 0 and the limit values are equal. F of x is continuous at x equal to 0. Now we will check x equal to 1. So similarly, limit extending towards 1 minus, we are coming from the negative side, so we will use this function which is equal to 0. Now limit extending towards 1 from the positive side will come, so we use this expression which is 4 into 1 equal to 4. Left hand limit not equal to right hand limit. F of x is not continuous at x equal to 1. Now we need to discuss the continuity of the function defined by this f of x, by this function. Now clearly when x is less than minus 1, function is continuous, f of x is continuous. Why? Because it has a constant scalar here, minus 2, so it is continuous. Similarly, when x greater than 1, f of x is continuous because it has a constant number 2 here, so it is continuous. What happens at minus 1 and 1? So this is the minus 1, here minus 1, and 1 and 1. We need to check what happens. So let us see at x equal to minus 1 will do. So limit extending towards minus 1, we come from the negative side f of x. So we use this expression, negative side, so which is minus 2. Similarly, limit extending towards minus 1, this is minus 1 from the positive side f of x. So we will be using this expression, 2x. 2 into minus 1 is minus 2. Similarly, f of minus 2 is this expression. Sorry, f of minus 1. I'm sorry, this is f of minus 1. We are finding at x equal to minus 1. So this has to be f of minus 1. So we'll be again using this expression, which is minus 2. So the function value at minus 2 and the two limits at minus 1, function value at minus 1 and the limit values at minus 1 are all equal. Function f of x is continuous at x equal to minus 1. Now we will check at x equal to 1 what happens. Again we will do same, limit extending towards 1 minus f of x. So x is 1 minus, so we are using this expression which is 2 into 1 equal to 2. Now limit extending towards 1 plus side we are coming. So we are using this which is again 2. Now f of 1 we'll be using this expression. So 2 into 1 equal to 2. Again, the function value at 1 and the limit values at x equal to 1, they are all same. So f of x is continuous at x equal to 1. In this we need to find the relationship between a and b so that the function is continuous at x equal to 3. If the function is continuous at x equal to 3, then limit x tending towards 3 minus f of x should be equal to limit x tending towards 3 plus f of x should be equal to f of 3. So let us find this limit from minus sign. If you are coming, use this expression. So it will be 3a plus 1 should be equal to, when we use from the plus side, use this expression. So it will be 3b plus 3. So 3a equal to 3b plus 2. This is the answer. This is the relation between a and b for this function to be continuous at x equal to 3. In this problem, we are given that the function is given by g of x equal to x minus x bracket. This is the greatest integer function. So we need to show that it is discontinuous at all integral points. Let C be the integral point. And we know that for greatest integer function, c plus h will be equal to c itself. What does it mean? If c is an integer, say for example this is 3, this is a small number 0.01, so 3 plus 0.01 will be 3.01, which will be 3 itself. Similarly, c minus h will be equal to c minus 1. If c is say 3, this is 0.01, so this will be 2.99, which will be 3 minus 1, 2. So let us try to find the limit. So limit x tending towards c minus g of x will be equal to limit h tending towards 0 g of c minus h. What is this? G of c minus h we will substitute here in this equation. This will be c minus h minus c minus h. C minus h we have seen is equal to c minus 1. C minus h minus c minus 1. This will be equal to 1. Now let us see limit x tending towards c plus, we will see on the plus side g of x, what happens? Limit h tending towards 0 g of c plus h equal to c plus h minus c plus h. But what is c plus h here? That is equal to c given here. So this will be c plus h minus c. This will be equal to h, which is 0. So this is not equal to this. The left hand limit is not equal to right hand limit. F of g of x is discontinuous at x equal to c. In this problem, we need to show that the function defined by x square minus sin x plus phi is continuous at x equal to pi. So how does this function look like? The first element is a polynomial, second is a trigonometric function, and third is a constant or a scalar. Now we see that a polynomial function is continuous, a trigonometric function is continuous, a constant or a scalar function is always continuous. So when we add all those functions, so we know that, for example, if we add say g plus h plus k function, where g of x plus h of x, k of x, we add the function, and if they are continuous, then the resultant function is also continuous. So f of x is continuous function at all real values. So it is continuous at all. So it is henceforth also continuous at x equal to pi. Now we need to find the discontinuity points for this function. So how do we see? We see that when x is less than 0, this is a trigonometric function divided by a polynomial. It is continuous. F of x is continuous at x is less than 0. Similarly, when f of x is greater than 0, when x is greater than 0, f of x is again continuous, because this being a polynomial function. And the question comes, what happens at x equal to 0? That is the critical point. So we will try to see what happens at x equal to 0. So we will find limit extending towards 0 minus f of x equal to limit h tending towards 0 f of 0 minus h, which is nothing but f of minus h. So we substitute here sine of minus h by minus h. So this will be equal to 1. Now we see the limit from the other side, 0 plus f of x equal to limit h tending towards 0 f 0 plus h. So we have to use this function f of h, which is equal to h plus 1. When h is tending towards 0, this will become 1. So we see that also we will see f of 0. F of 0 we will put it here, equal to 0 plus 1 equal to 1. We see that the function value f of 0 is equal to left hand limit equal to right hand limit. The function is continuous at x equal to 1 also. So less than 0 also continuous, greater than 0 continuous, at 1 also continuous. So there is no discontinuity in this function. In this problem, we need to find whether f of x is a continuous function. Clearly, when x not equal to 0, when x is not equal to 0, this function is continuous because it is a product of a polynomial and a trigonometric function. So f of x continuous when x not equal to 0. But what happens at x equal to 0, we need to check. So again we use the left hand limit and the right hand limit. So we can write limit extending towards 0 minus f of x equal to limit h tending towards 0 f of 0 minus h equal to limit h tending towards 0 f of minus h. So this will become limit h tending towards 0 minus h the whole square sine of 1 by minus h, and when h is tending towards 0, this will become 0. Let us see limit x tending towards 0 from plus side. What happens? F of x equal to limit h tending towards 0 f of 0 plus h equal to limit h tending towards 0 f of h limit h tending towards 0 h square by sine 1 over h. Again when h is tending towards 0, this will become 0. What is f of 0? F of 0 is this point is equal to 0. Now the function value at 0 and the two limits, they are all equal to 0 at x equal to 0. So f of x is continuous at x equal to 0 also. So it is continuous for all x belonging to R. We need to find the continuity of f defined by this. Now we observe that this is a trigonometric function and this is a trigonometric function. So trigonometric functions are continuous, and when they are added they are further continuous. So when x not equal to 0, f of x is continuous. What happens when at x equal to 0 is important? Let us try to find it through limits. So limit x tending towards 0 minus f of x equal to limit h tending towards 0, f of 0 minus h equal to limit h tending towards 0, f of minus h sine of minus h minus cos of minus h is equal minus sine h minus cos h. When h is tending towards 0, this will be minus 1. Let us find limit x tending towards 0 from positive side. When we are coming, of x will be limit h tending towards 0, f of, it will be h. So this will be sin h minus cos h. When h is tending towards 0, this will become 0. So this will be again equal to minus 1. And what is f of minus 1? Sorry, f of 0. F of 0 is minus 1 given here. F of 0 is function value at x0 is minus 1. So the function value, the two limit values are all equal. So the function is continuous at x equal to 0 also. So it is continuous for all x belonging to In this problem, we need to find the value of k so that the function is continuous at x equal to pi by 2. We need to evaluate k. So how do we know if a function is continuous at any point? The left hand limit should be equal to right hand limit should be equal to f of pi by 2, which is equal to 3 given here. So we can find any one limit and equate it to 3. Let us put x equal to pi by 2. Say left hand limit, we will compute left hand limit x tending towards 0 minus f of x equal to limit h tending towards 0. So this will be f of minus pi by 2 minus h, x tending towards pi by 2. So limit h tending towards 0, f of pi by 2 minus h. So we will substitute here. Limit will always be there, k into cos pi by 2 minus h divided by pi minus 2 into pi by 2 minus h. What is this? This term is sin h. Limit h tending towards 0 sin h, k sin h. This we simplify, what we will get 2h. So we can take k by 2 outside. So limit h tending towards 0, k by 2 sin h by h. This term is 1. So this will be equal to k by 2. So one of the limit is k by 2. But this is given as one of the limit is equal to 3. So k should be equal to 6. This is the final answer. Now in this problem again we need to find the value of k so that the function is continuous at x equal to 2. So again we know left hand limit equal to right hand limit equal to function value at x equal to 2 is given 3 here. So we will write 3 here. Now we will find left hand limit equal to limit x tending towards 2, say 2 minus, we'll put it, f of x equal to limit h tending towards 0, f of 2 minus h, we will substitute here k into 2 minus h the whole square. Now when h is tending towards 0, this will be k into 2 square equal to 4k, but left hand limit is equal to 3 given here. So 4k equal to 3, k equal to 3 by 4. In this problem again we need to find the value of k so that the function is continuous at x equal to pi. For a function to be continuous, left hand limit should be equal to right hand limit should be equal to f of x equal to pi at, what is the value of x equal to pi, function value? So at x equal to pi it will be k into pi plus 1. So if we evaluate any of the limit, say right hand limit, and equate it to k pi plus 1, we can get k. So let us find right hand limit. So limit x tending towards 0 positive, we are coming from this side. So this will be f of x should be equal to limit h tending towards 0, sorry, x tending towards pi, this is x tending towards pi. So this will be f of pi plus h, which is equal to cos pi plus h. This is equal to minus 1. When h is tending towards 0, cos pi is minus 1. So we can equate these two now. So k pi plus 1 is equal to minus 1, k pi equal to minus 2, k equal to minus 2 by pi is the answer. This again we need to find the value of a and b so that this is a continuous equation. So when we need to find two variables, there should be two equations, then only we can find. So here we see the critical point is at 2 and at 10. So at x equal to 2, if the function is continuous, then at x equal to 2, if function is continuous, ax plus b should be equal to 5. Ax plus b should be equal to 5. We put x equal to 2 here. So this will become 2a plus b equal to 5. This is first equation. Similarly, at x equal to 10, if a function is continuous, then ax plus b should be equal to 21, where x is 10. So this will give 10a plus b equal to 21. So we can easily solve this. This is 10a. We change the sign here, cancel this. So this will be equal to 8a equal to 16. A will be equal to 2. So we can put a equal to 2 in this equation. So 2 into 2 plus b equal to 5. B will be equal to 1. So a equal to 2 and b equal to 1 is the final answer.